Welcome. In this unit, we'll be learning about trigonometry. Trigonometry is the study of angles of triangles. Let's look at the technical definition. Trigonometry is a branch of mathematics that deals with the relationships between sides and angles of triangles and the calculations based on them, particularly involving trigonometric functions. You can think of trigonometry as kind of having four components. We want to study both triangles, circles, and the relationships between the angles of these objects. We look at three main trigonometric functions, sine, cosine, and tangent, and we want to study oscillatory behavior, as we see in this graph here, the functions that oscillate back and forth. Let's look at a simple example. When you were a kid, you might have had a slinky toy. Well, the slinky toy is a great example of oscillatory behavior. Notice if I take my slinky and bounce it, I get some oscillations. The slinky oscillates back and forth. You can also take the slinky and make some waves. When I make waves with my slinky, that's another example of oscillatory behavior. Notice that the polynomials we've been studying so far won't be able to account for this type of behavior. Polynomials can have some wiggles to them, but eventually they either tend to infinity or minus infinity. So we need some sort of function with periodic behavior. By periodic, I mean it oscillates with time and does the same thing over and over again forever and ever. We're not going to play with this slinky forever, though. Let's look at the correspondence between circles and triangles. You might not think these two things have a lot in common. If we consider a circle of radius r, and we can think of a point on the circle with coordinates x, y, we could create a triangle from this circle by dropping a perpendicular from the point x, y onto the x-axis. Then we have the triangle labeled as you see here. This is often called the unit circle when I replace that radius with 1. So take the circle I had before, replace the radius with 1, we get a unit circle, and we call the angle that radial line makes with the x-axis an angle theta. Theta is just a Greek letter that we often use for angle. There's nothing special about the letter theta. It's just a convenient way to let people know we're talking about an angle there. If we just look at the triangle from this picture, we can think about, well, how would we determine what theta was if we knew some of the sides from that right triangle? So with my right triangle, I have three kind of main sides to the triangle. There's the hypotenuse, the side opposite the right angle. There's the adjacent side, the side next to the angle I'm interested in, theta, and the opposite side, the side on the opposite side of the triangle from theta. This brings us to those trigonometric functions we mentioned before. We have three main trigonometric functions we'll talk about. That's the sine, the cosine, and the tangent. These three functions can be related to the right triangle via the relationship that the sine is the opposite side over the hypotenuse, the cosine is the adjacent side over the hypotenuse, and the tangent of an angle is the opposite side over the adjacent. A lot of students like to use the mnemonic SOHCAHTOA to help you remember this. SOHCAHTOA basically is so, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and TOA, tangent is opposite over adjacent. Let's take some more look at these trigonometric functions. Well, we said that this triangle was also related to the unit circle, or any circle for that matter. The unit circle is just a special circle with radius 1. On that unit circle, there's several angles that we study a lot because these are values that we can evaluate explicitly for a circle. So those points x, y on the circle that are interesting or we know the values of would be things going from the x-axis along the unit circle to angles like 30 degrees, 45 degrees, 60 degrees, 90 degrees, etc. These special angles are just values for which the x, y coordinates on the unit circle are easy to find. Well, we don't always work with degrees in mathematics when we're looking at trigonometric functions. We also work with something called radians. Most of you probably know a circle has 360 degrees. What you may not know is that we also can say a circle has 2 pi radians. The relationship between degrees and radians is simply that 360 degrees equals 2 pi radians. So in these two circles, I'm just depicting the degree value and radian value of some key angles on the unit circle. We can also look at the trigonometric values of the trig functions at those key angles. So for example, I could make a table of my sine, cosine, and tangent with those angles theta as the input. Notice here we have some values. By the end of this course, you definitely want to memorize this table. It takes a little bit of work, but it will be worth it, particularly when you get to calculus. Being a master of trig values is super important. Notice on this table I snuck in 3 extra functions. I haven't talked much about these 3 extra trigonometric functions because they're basically directly related to the ones you already know: sine, cosine, and tangent. The cosecant is 1 over sine, the secant of theta is 1 over cosine, and another trig function, the cotangent, is 1 over the tangent, or cosine over sine. Let's look at our 3 main trig functions. I said that they correspond to oscillatory behavior, or an oscillating function. Just looking at a triangle, it may not be clear to you that those are oscillatory functions. But basically, as I change an angle, theta, and input it into this function, I get differing values, and these values repeat with time. Each of these functions has what we call a characteristic period, or the amount of time before that function repeats again. Up on this graph, you see our sine, our cosine, and our tangent graphs. You'll be working with these more in future units. Another thing that you'll be learning a lot about is trig identities. Trig identities are basically relationships between our trig functions that help us solve equations and manipulate expressions involving the trig functions. There's quite a few of these. Many of them you'll want to memorize. Some of them you'll want to make sure you know how to derive or figure out what the relationship between these quantities is. You'll be spending a lot of time working with trig identities. One trig identity you may have already seen is Pythagorean theorem. You may have seen this in a geometry course. The Pythagorean theorem says that a squared plus b squared equals c squared. If you remember what that means, for a triangle, one side squared plus the other side squared gives you that hypotenuse squared. The way we say this with trig functions is sine squared plus cosine squared equals 1. This is just an example to give you a flavor for what these trig identities are all about. They're relationships between your trig functions that give you an expression that might be helpful in evaluating some sort of equation. In this unit, you're going to learn several things about trigonometric functions. First of all, you're going to learn how to work with angles, convert back and forth between degrees and radians, and figure out which angle are you talking about. Do you want the smaller acute angle or the larger obtuse angle when you're drawing these pictures? You'll also learn how to utilize right triangles and the unit circle to find angles and lengths in triangles and points on the circle. Finally, you're going to evaluate and graph trig functions and use those trig identities that we talked about. You'll solve trig equations, and most importantly, you'll learn to use trigonometry to solve real-world applications. What might those real-world applications be? Well, applications of trigonometry include things like astronomy. Trigonometry was actually first developed to help talk about astronomy problems. They wanted to figure out things like where bodies were going to be in the sky at different periods of time, and that involves a lot of triangles. If you think about it, if I know the planet was here one day and up there the next, I'm making some sort of angle that I can use trigonometry to deal with. Other things include geography, optics, architecture, mechanics, seasonal phenomena, anything that changes with time in some sort of oscillatory behavior, like the seasons or the temperature as a function of time throughout the year, is something that might be suitable for study with trig functions. Signal processing is another very popular area to use trigonometry with, because most signals you can think of as waves, and studying those waves involves trig functions. Well, I hope you enjoy learning about trigonometry. Thank you, and we'll see you next time.